For the last part of this activity, I want you to go and try and use Desmos again to help answer a couple questions. Um, this is now our second time really trying to introduce Desmos. And so I really want us to try and become more comfortable and see how it can help us answer some questions that we're being asked of. So to use Desmos to answer the following questions, go to the drag racing graph in Desmos by clicking here. If you click this, it's going to open this data set here. You can see that you have data points and they're on the graph here. We also have distance in meters and time in seconds. Okay, so this is a distance over time graph. And I also point out that the data is not going in a straight line, but it's following a curve. So that is an example of our quadratic pattern. So we are looking at an example of acceleration here. So then use the data table and graph to help answer the questions. Use the following data points to solve for the rate of acceleration. And then remember, you can click on the data points to see their value. So here's the data points. You can do it from here, or you can go from the activity in Desmos. But one last little hint. You can use the data points to solve for velocity. We hopefully by now we're kind of remembering that. And so you can then you can calculate the initial velocity and the final velocity to help you solve for acceleration. And so to do that, we want to remember that velocity equals distance divided by time. And so we can then click on the graph and get our initial velocity here. And x is always going to be recorded first. So this is x comma y, or in other words, time and distance. And so your time is 0 seconds, and your distance represented by this data point is 0 meters. So to solve for that velocity, you would do distance, 0, divided by time, 0, and your velocity would be 0 meters per second. Okay, so it started off sitting still or parked. Then this drag racer accelerates and it gets to its final velocity, which would be the peak here. So if I click that, this again, 416 is my distance. 4 is my x value, so that is my time, 4 seconds. And so I would take 416 divided by 4. And so just to show this real quick, again, we are solving for acceleration, so we need your final velocity minus your initial velocity divided by time. And so if I plug in some numbers here, we had to solve for our initial velocity, 0 meters divided by 0 seconds equals 0 meters per second. So our initial velocity is 0. And our final velocity was 416 meters, and that took 4 seconds. So 416 meters at 4 seconds. And if I put that into the calculator, that should come out to 104 meters per second. So now you can see your initial velocity was 0. Your final velocity was 104 meters per second. So then your time value, we want to think, well, how long did it take to get to this point? And we know that because we can look along our graph and see it took 4 seconds. It's also the time we used for that data point. So our time in this scenario was 4 seconds. Now if I plug this in, I have 104 minus 0, which again, you don't really have to show, but it kind of helps you keep track of your equation here. I want to enter that, 4. So if I write this again, this is really acceleration equals 104 meters per second. Ooh, sorry, meters? No, yes, that is meters per second. That's velocity. 104 meters per second divided by 4 seconds. And therefore, my A value equals a number, which I'm not going to give you, but you can enter this into your calculator and get your number. And your units are meters per second, because that's this right here, per, whoops, second. Okay, so meters per second would be the rate of acceleration. This number is going to help you in the next problem. So we're going to want to refer back to this. Now that you've entered your answer here, don't forget that. It says now use the quadratic equation in Desmos to test or fix, possibly, your answer above. Plug in your acceleration answer from question 8 into the A value in the equation. So this is the equation, y equals ax squared. And again, that's the quadratic equation. And this is what we're going to be using for acceleration when we're using a distance over time graph. Okay? And then our goal is that our quadratic pattern is going to line up with our data points. And you're going to share that image back into this space provided. So again, I want to take the answer from here and see if it lines up with my data points. But I'm also going to show you another trick. So if I'm here, right, here's the data points. I've got the data here as well. And I've already put in y equals ax squared for you. So again, if you are following directions, you should put in the answer. Let's say you got 30 for answer in number 8, and you'd want to see if it lines up with your data points. And you can see it doesn't. Okay, so my little secret for you and why this can be helpful is we have this A value, and without even having to solve all the final velocity, initial velocity, and solve for acceleration, I can find the rate of acceleration by taking this slider and seeing if I can get it to line up with my data points. And I can. And so now, little sneak peek, if you're watching, here you go. The answer for question 8 should be 26 meters per second per second. And then so if I'm finishing now question 9, I have my line going through my data points, and it asks me to share. So you want to click this share button in the top right corner, export image. It's going to give you a little kind of menu here to make some changes. And then you can download that, and it's going to go to your download file. You can see it just showed up here for me, my Desmos graph. Then I go back to formative. I can click show your work. And on the left, you have this little image button. When I click on that, I can then upload an image from my computer or Google Drive. I know that the image I just did went to my downloads. And now that I got 100 images in here, it should be called Desmos something. There it is. I believe that's the correct one. So I'm going to go and open that up, hit add, and there it is. I have now added that graph into Desmos. When you click it, now your teacher will be able to see that. If you have any questions, please let me know, or maybe rewatch this and go step by step.